is Grace the only one or the largest one?
Oh, no. There are many producers of zeolites. And again, Grace does not participate in the largest but more commoditized detergent zeolites part of the business.
I see.
Familiarity of that, but other companies like the UOP is a large manufacturer of zeolites. There's a company called Zeochem, another company called Zeolist. See who else? BASF is a large manufacturer of zeolites. Again, zeolites are an essential part of fluidized cracking catalysts, as well as being used in absorbent applications. So Albemarle, W.R. Grace, and BASF are the largest manufacturers of fluidized cracking catalysts. So they all self-produce zeolites for that. UOP makes a lot of processed zeolites, as well as zeolites for hydrocracking. And I'm not that familiar with the detergent zeolite market. But again, it's there's a number of manufacturers, and it's a very low end of the market in terms of value added, converting that from a silicate to a zeolite.
Yeah. If we go back for a moment to the precipitated silica for tires, I guess those industries are the health of the industry is linked to whatever is going on with the automotive industry.
Yes.
And with also the other part is the tire manufacturers. Again, there are not too many. So the market dynamic is not very easy, I guess.
There are a number of pretty good size tire manufacturers. In fact, Evonik, it was last year, they bought Huber silicas. So Huber was very big in precipitated silica, not for tires, but for consumer applications, including toothpaste. So precipitated silica is used as an abrasive and a thickener for toothpaste, and Huber is very big in that market, but they sold that silica business to Evonik. Evonik is very big in the industrial applications of precipitated silicas. That would be for paints primarily, but the bigger part would be tires in that industrial kind of segment for precipitated silicas. And at that same time, so I think they paid $600 million for Huber. And let me see. So 2016, they bought Huber for $630 million. And they also built a $120 million precipitated silica plant in Charleston, South Carolina for tires. And because in Charleston was a center where there were several tire companies that had located to manufacture tires. So one of the things I should add about precipitated silica is it's a very fluffy material. It's got high porosity, and so the bulk density is pretty low, and shipping costs can be significant. So when you ship by ocean, you're paying by volume. When you ship on the road, you pay by weight. I think 40,000 pounds per truckload. But you have a hard time getting that much precipitated silica in a truckload. So either way you ship it by boat or by truck, it's a fairly expensive proposition to transport precipitated silica. So you tend to want it to be close to where it's going to be used. You can get away with a little bit more in some of the specialized applications like paints, where you can command a premium because of the the particulars of your precipitated silica. But there's significant investments being made for precipitated silicas for tires, and seems to be a good. In fact, that's the fastest, largest segment for specialty silicas is tire applications, followed by polishing, the electronics market, which is like colloidal silicas are used for that, and that market is growing primarily in Asia because a lot of the electronics manufacture is done in Asia. Europe, North America, Asia, all of those will see an influence of tire manufacture and consumption of precipitated silicas for what are called green tires.
Hello?
Hello?
Esteban, you still there?
Yes.
Sorry.
Hi, is this Jeff that just called? This is Jim Bogdanor.
Hi, Jim. Yes, it is. I apologize. I had a bit of a mix-up here thinking of a different call, so I just realized we were on for today. But are you guys pretty much finishing up here, or?
Well, we started at 2:05, so we discussed a lot already.
Okay.
But no, Jim has been commenting on the different market segments for silicates and silicas and the different type of silicas and all that. So I guess we can do some catch up later, Jeff. We continue the call now, if you don't mind.
One thing that might help, for example, is the way that INEOS and PQ, they combined their silicas businesses, and the way that they're structured, I think, kind of reflects where the values are for silicates and specialty silicas, which would be a downstream consumer of silicates as a raw material. So they have, in their strategic business unit, they have a silicates and zeolites business, which is the detergent application and what they call industrial applications, which would include coatings and the paper applications for their silicas. They put their zeolites in that application area as well. So they would be making detergent zeolites, for example. And then in the silica category, which is going to be the precipitated silica and silica gel, they have beverage. So they're very big in using silica gel to treat beer to remove protein. So what happens is if you leave that certain kind of protein in the beer, when you chill the beer, it makes a haze, which many people find objectionable. So they call that chill proofing. So companies like, Ambev, which is Anheuser-Busch, and others will use that along with other products to treat beer. Also, it's used for refining edible oils to remove phospholipids from like soybean oil streams. Personal care, which would include toothpaste applications. So that's a thickener and abrasive, as well as could be used in cosmetics as a free flow agent for powders. It can be used in sunscreens to help minimize the absorption of ultraviolet rays on the skin, so it's a barrier to that. And then in plastics, in films, micronized silicas are used to reduce what's called blocking, so that you use that on a film to keep the film layers from sticking to one another, so it's called an anti-block. And then finally, they have